the region in the first quadrant, bounded by the curve y equals 4x squared minus x to the 4th, so there's this weirdo looking quartic that we've got here. That region, which I've shaded in yellow, is, and the x-axis, sorry, is rotated about the y-axis. There we go. Find the volume of the solid of revolution generated. Now let me just point out quickly, some people have been asking me, oh, can we do these early questions by like just doing it the 2-unit way? Because you can. I'd like you not to. I'd like you to sort of demonstrate, like, yes, I know how slices work, I know where they come from. But I will point out that even if you did it by a 2-unit method, that is volumes by slices. We're just not describing the language, okay? So this is what we've got, and I'm just gonna put it out there. I don't expect you to make a diagram, you know, this colorful and this, you know, etc. As you can see, even I cheated a little bit. I could have graphed it, but you know, this looks better. However, you absolutely need to work towards this. When I've marked students who've gotten a volume wrong, I can, in a good 3/4 of cases, trace it back to their diagram being unclear and therefore unhelpful when they're trying to work out these things, which of course gives you the integrand. And people can generally integrate okay. And the kinds of functions you get are often polynomials. It's not like you get something which just doesn't work. You just get something that's wrong, okay? So, I am rotating around the y-axis here. So my first line is going to need to look something like this. V equals, because I'm going around the x-axis, around the x-axis, you can see my slices are perpendicular to the axis of rotation. I'll say that again and again and again. That's what makes slices slices. So my height for each bit is delta y. Is that okay? So let's begin by saying limit as delta y approaches 0. I'm adding up a whole bunch of things. Because I'm going up along the y-axis, I'm going to have a y equals something. Where do I go from? Bottom to top. You can actually just read them off, right? 0 to 4, very good. Which of course you'd actually have to go ahead and work out, but you can see it for now. And then I'm just going to write you can see, I'm going to get an annulus every time I slice across, right? So here is my annulus volume. Okay, great. But then you encounter this little difficulty in that R and R, there's a couple of problems. The first thing is, this is R should be a function of Y, right? I don't have a function of Y, I have Y as a function of X. That's my first dilemma. The second dilemma is, I'm usually used to getting this part from like a constant or some function, and this part from a different function. You remember the one we started with this morning? We had e to the x, we had 1 on x, and you're like, oh, okay, well I get one bit here, one bit there. Okay? But both radii here, the inner and the outer, come from the same function. So how do I get 2 radii out of the same function? How do I distinguish between these, this radius and this radius, okay? Now those 2 problems are both solved with the same step. What I need is a function of y. I need this function as a function of y, okay? So in other words, I need an x equals out of this, right? Or, more usefully, I need an x squared, right? Which is going to be important for us here in a second. So, with me, let's just write down this function. I'm going to put this to one side. And I've just got to, before I get to actually integrating, I need to work with this function and work out what on earth is going on. I want x squared as a subject, or x as a subject would be nice, but I notice it's a quartic, so if I can get x squared, I'll be happy, okay? Now, it's not presenting itself in a very nice form for us. I'm going to do one thing, which doesn't look like it's a dramatic change, but this is what I'm going to do. Now, you look at that and you're like, okay, pull on all of the knowledge of polynomial functions and quadratics and that kind of thing that you've learnt in the past. I want x squared to be the subject. So what am I going to do with that? Would you like another clue? It's not much of a clue, but I think it's the last clue that I can give before I give you the answer. If I gave you a question like this, let's give you some awkward numbers. Okay, and I said, can you solve this for me? You solve it. You know exactly how to solve it. Solving, of course, means making x the subject. That's what it means. Solve the equation. What would you do for this thing? You'd go for the quadratic formula, because you're like, I can't think of 7th prime. Get lost, okay? So you go straight there. You might even get some complex roots, but that's fine. This is exactly like this. except that it's not a quadratic in x, it's a quadratic in x squared, which happens to be exactly what I want, right? So let's have a go at this. X squared equals quadratic formula. How does it start? It'll be minus b, which is 4, plus or minus b squared minus 4ac. Yes?
Why isn't it a constant so often?
Okay, now it's not a constant, but it is the coefficient of the term which has no x squared terms in it, right? So we're used to thinking of ax squared plus bx plus c, where c is constant, but it doesn't have to be constant. What it really is, it's the term with no x squareds on it. Just like this is the term with no x's on it. Or this is the term with no u's on it, right? It's just whatever variable you're interested in. Divided by 2a, which is 2. Okay, I can march through this. Looks like I can take a factor of the square root of 4 out, which means I'm going to end up with this, yep, divided by 2, and then I simplify. Excuse me. Is this what you expected? Is this what you expected?
Did we expect anything?
What were we expecting? Let's just dig into this a little bit more, and you don't need this line because we actually want x squared, but just out of interest, let's just write this because this is true. What does this indicate? Okay. Well, x is now a function of y. It has a plus or minus on the front. What does that mean? Plus or minus. It means horizontally I have a pair of things, which is exactly right. It's an even function after all, right? So it's like, look, there's a left-hand side, that's the negative x, and there's a right-hand side, that's the positive x. So far, so good. And then what's going on in here? About x equals 2 and root 2 and x equals negative root 2, about those two lines, you again get two branches. Right? There's a negative part which goes to the left, and there's a positive part which goes to the right. Well, you have to watch out because actually two positives and two negatives interacting there. Okay? In other words, you have 4 branches. 4 branches. You've got this one and this one, which are both on the positive x side, and you've got this one and this one, which are both on the negative. Okay? So which ones do I want? Let's come back to this. Which one is which? For x squared equals this, right? Excuse me. One of them is the inner radius. I'm going to call that r squared. And one of them is the outer radius. Which one is which?
The outer radius is the one that has the plus. And then the inner one is the one that has the minus.
Okay,
Inner
now,
radius is smaller than the-
let's just pause for a second, right? Because this is confusing. What's going on, right? I know that there's a negative case and there's a positive case, but I need to work out which one's which. Now, thankfully for us, the reason we called them big R and little r is because one has to be for every value that I've chosen except that one. Big R has to be bigger than little r. Do you agree? Does that make sense? So therefore, the easiest way to determine, well, which one is which, is to say, look, 2 take away a number, and that's positive, mind you, because it's a square root, and it's all real, yeah. 2 take away a number must be smaller than 2 plus the same number. Do you agree? Has to be, right? So therefore, that's how I know this is the outer radius. Simple way of doing it. Don't go rocket science. Just work out which one's the big one and which one's the smaller one. I've left them in r squared and r squared form because that's all I need. I don't actually need to know what r is by itself, even though I've written that here. Well, we got to square those things if we find them out. So I've already squared them. So now I'm actually ready to solve. Okay, let's do this. I've accounted for the fact that there's slices happening, so now I'm going to turn this into an integral from 0 to 4. What am I getting in here? Pi times what? What's capital R squared? That guy, right? Take away little r squared, which is this guy. And I've accounted for the limit, so now I write dy instead of delta y. Okay, some sweet cancelling happening in here, right? I'm going to take a pi out, so that leaves me with that. And then what do you get here? The 2's cancel, which leaves you 2 root 4 minus y, dy, okay? And after the integration topic we just did, we can make mincemeat of this, right? I'm going to pull that 2 pi out the front. This is 4 minus y to the half. 4 minus y to the half. So the first thing I'm going to do is slap a minus sign for the inside derivative. That half is going to become 3 on 2, which means I'm going to have to divide by 3 on 2, which gives me 2/3. Yes? And then I write it with the increased power from 0 to 4. Yep. Now let me just double check that. Do I differentiate this and get this back? The 3 on 2 and the 2 on 3 will cancel. Thumbs up. The minus sign from in here cancels. Thumbs up. I've got my square root of 4 minus y just like I wanted. Okay, let me tidy this up just a tiny bit before I evaluate. I'm going to take that minus 2/3 as a constant out there, which leaves me with this. Now at this point, I raise a little bit of an eyebrow because I'm like, volumes, better be positive, right? But I've got a negative sign out there. What's with that? Why is there a negative sign? Yeah.
It's gonna get cancelled.
That negative sign will cancel. It must, because look, when we evaluate these boundaries, let's put this guy all the way out the front. Here, the first evaluation gives you 4 minus 4, which is 0. And then the second one gives you 4 minus 0. 4 to the power of 3 on 2. 4 to the power of 3 on 2. That's the square root of 4 is 2, and then you raise it to the third power, so that's 8. So just like we were hoping, those double negatives cancel out, and you get a volume. Oops, sorry, 32. 32. I was just writing the 8.
It was tricky. It's emails.
Okay, yeah, thank you, you're awake. So what was hard about this question? Ooh, getting a whiteboard eraser that works was part of the hard part of this question. What was hard about this question? What can you tell me? What do you think was tricky about it?
It looked too cool, so it looked intimidating.
Nah, it looks awesome. Look at that diagram. It must be a hard question, right? Finding the radii of my annulus, the inner and the outer ones, that was non-trivial. That was some serious work. And even after you knew, oh, I have to do something with this, I don't think it was obvious to like, oh, of course. It's like, well, okay, now you've seen this, and you have to pull out this trick a lot because, of course, we usually get our functions in terms of, as functions of x, right? And if you're rotating this way, you need it as a function of y. So you're going to have to do this change in the future. But as you can see, it's not impossible. Okay?